Hello friends, welcome to my YouTube channel Mustaq Noor Academy. Friends, in this video I will show you how to perform an integrator amplifier using op-amp 741. In order to perform this simulation, I am using the simulation software that is Proteus. First of all, let's see its circuit diagram. Here circuit diagram is as follows. It consists of one op-amp and in feedback it is having a capacitor that is of 0.01 microfarad and a feedback resistor of 1.59 kilo ohm. At input we have to connect 100 ohm resistors and we have to apply the square wave at the input and we have to observe the output at pin number 6. When we apply the square wave, then we have to get a triangular wave. Hence, in this way, it integrates the input value. Now, it's time to perform its simulation. Let's do it with the help of simulation software that is called Proteus. First, we have to select here. First, go to component mode, click on P. First, we have to select the op-amp, type it as op-amp. Once we type as op-amp, here the different op-amp ICs are going to appear. We have to select the 741 here. Click on 741, then double click on it, and that is going to add in this list. Likewise, we also need a resistor. Type resistor in keywords. Here we have to select generic symbol resistor. Just double click on it. We also need a capacitor. Type capacitor here. And here you can see that different types of capacitors are going to appear in this list. But we need a capacitor that is generic non-electric capacitor. Just double click on it and click on OK. Once we select the required components, now it's time to build a circuit. Click on 741 and click on workspace. Here you can see that the pin number 3 is above and pin number 2 is below. For the sake of convenience, I will make it Y mirror. Hence, the pin number 2 appear on the upper side, pin number 3 appears on the lower side. Now we have to connect a resistor at the input. We also need a resistor as well as a capacitor at the feedback. It's change its value. Here I have to make it as 100 ohms. 100 ohms. Click OK. And in the feedback, we need capacitor as 0.01 microfarad and feedback resistor as 1.5 kilo, 1.59 K. Click on OK. Let's make the connection. Connect this 100 ohm to pin number 2 and this feedback capacitor to pin number 2. Connect this resistor here and one end of capacitor is connected to pin number 2 and in the end we have to connect to pin number 6. Likewise, we have to connect the resistor in the feedback. We need a ground as well as power supply. For that, click on terminal mode, select ground here, make the connection. We also need a power supply. Click on power. I will Y mirror it, make the connection to of the power pin, and here we have to connect the pin number 4. Since the pin number 4 requires minus 12 volt, hence we have to type here as minus 12. Here type it as plus 12, plus 12. Click on OK. Friends, we are done with the circuit construction. Now it's time to apply the input and observe the output. Here we have to apply the signal and in the output we have to observe the output. For that, go to virtual instrument mode. Here you have to select signal generator. Select the signal generator here. Connect the positive to the resistor and negative to the ground. And in order to observe the output, we need the oscilloscope. Click on oscilloscope. Connect A channel to the input to observe the input and connect B channel to observe the output. Friends, we are done with the circuit connection. Let's run the simulation. Just click on this run button. Here we can see that the signal generator is appear on the upper side and this is the lower side. First we have to set the values. Here you can see that there are four tabs. The first one is multiples. First we have to select the frequency here. For example, I will select this as 1 kilo. If I select this as 1 kilo ohm, here I can get its multiple values. Likewise, here this is the voltage, peak to peak voltage. Here we have to select the range as 1 volt. Here we can change its voltage values with the help of these multiples. Now I will set the input voltage as 1 volt and frequency as 10 kilo ohm. Since I have connected the input to channel A, hence with the help of this voltage per division tab, I can change its scale. Now I will change its scale. Before changing its scale, one thing we have to keep in the mind that we have to keep this internal knob arrow to the maximum values. Likewise, the channel B, that is of blue color, is connected. Here I will change its scale. Now since I apply the 10 kilohertz, hence the signals is not visible properly, change it the time scale. This is the time scale here which is applicable to both channel A and channel B. Friends, here I had applied the sine wave, hence I am getting the integration of this. If I apply the square wave, just change the waveform. Here just click on this button. Here you can observe that when I apply the square wave, here I am getting the triangular wave. If I change this, even this frequency, I will change its range here in order to get the more than 12 kilohertz. I will change its frequency. Friends, here you can observe that as I changing the frequency, I am getting the waveform. Here we can observe that when I apply the square wave, I am getting the triangular wave. Friends, in this way we perform the integrator amplifier using op-amp 741. Friends, in order to get these kind of very informative video, please like and subscribe to our channel. Thank you.